we have seen that cations or positive ions are smaller than the parent atom, while anions or negative ions are larger than the parent atom. Positive ion is smaller than the parent atom, while negative ion is larger than the parent atom. So much we have seen in the last class. Now let us see a point that is isoelectronic species. Isoelectronic species. What are isoelectronic species? See, there will be atoms or ions or any other species which will be having the same number of electrons. The same number of electrons. Such a species may be an atom or maybe an ion. That is called the isoelectronic species. So, isoelectronic species will have the same number of electrons. Same number of electrons. Such species are called isoelectronic species. For example, you take Na plus ion, then you take Mg plus 2 ion, then you take F minus fluoride ion, then O minus 2 oxide ion. You consider these ion species and you count the number of or calculate the number of electrons in each species. Here we have taken some ions. Say, need not be always ions, maybe atoms also. So let us find out the number of electrons and protons in the given species. You go to, say, Na plus ion, go to Na plus ion. In Na plus ion, what will be the number of protons? What will be the number of protons? Atomic number of sodium is equal to, come on? 11. So there will be 11 protons. There will be 11 protons. If it is sodium atom, what will be the number of electrons possible? Achut. Number of electrons possible if it is neutral
10.
atom.
10.
Neutral atom, sodium neutral atom.
11.
The number of electrons and protons will be the same in the neutral atom. The neutral atom, the number of protons and electrons will be the same. If it is sodium atom, there will be 11 electrons, sodium atom. But you are given Na plus ion, positive ion. Na plus ion is formed by the removal of one electron. So Na plus is having one electron less than the sodium atom. In sodium atom, there are 11 electrons. But in Na plus ion, there will be only electrons. That is equal to 10 only. There will be 10 electrons. 1 electron less in Na plus. Now you come to Mg plus 2. Mg. Magnesium atomic number is equal to 12. So the number of protons are in the nucleus. So there is no change for the nucleus during a chemical reaction. During a chemical reaction, there is no change for the nucleus. The change is only for the electrons. Addition of electron or a loss of electron or a share. It is only a play, a game of electrons. A chemical change is a game of electrons. It has nothing to do with the nucleus. There is no change in the nucleus. So there is no change in the number of protons. There is no change in the number of protons during a chemical change. You come back to Mg plus 2. Now, atomic number of magnesium is equal to 12. Therefore, number of protons in the nucleus is equal to 12. It's equal to 12. But what about the number of electrons in Mg plus 2? If it is Mg atom, there will be 12 electrons. There will be 12 electrons if it is Mg atom. But it is Mg plus 2 ion. So, 2 electrons are removed. When 1 electron is removed, plus 1. 2 electrons are removed, plus 2. 3 electrons are removed, plus 3, like that. If it is Mg atom, there will be 12 electrons. But it is Mg plus 2 ion. Therefore, 2 electrons less than the atom. So, electrons will be 10 only. There are only 10 electrons. So, 10 electrons and 12 protons. 12 protons plus 12. 10 electrons minus 10 plus 12 minus 10. And so the resulting ion has plus 2 charge. See here. Plus 2 charge. Okay. Now you come to F minus. Fluoride ion. Fluoride ion. Fluorine. Atomic number of fluorine is equal to 9. You must study at least up to atomic number 30 zinc. Zinc. You must study. So atomic number of fluorine. Atomic number of fluorine, that is equal to 9, and therefore number of protons is equal to 9. Then what about electrons? If it is fluorine atom, there will be 9 electrons. 9 electrons. But this is fluoride ion, F minus ion. There is minus 1 charge. If there is minus 1 charge, 1 electron is added. Minus 1, 1 electron is added. Minus 2, 2 electrons are added. Minus 3, 3 electrons added. Minus 4, 4 electrons are added. Here it is F minus. Minus means minus 1. Minus 1. So, 1 electron extra is added to the fluorine atom. So, the total number of electrons will be, Achyut, can you say? That is equal to 10. 10 electrons. 10 electrons. Protons, 9. Electrons, 10. That is why the species, the ion has minus 1 charge. You come to O minus 2 ion, oxide ion, oxide ion. Oxygen atomic number is equal to 8. Oxygen atomic number is equal to 8. Therefore, number of protons is equal to 8. Number of protons is equal to 8. And if it is oxygen atom, there will be 8 electrons. But it is O minus 2 ion. So 2 more electrons are added. So total number of electrons will be 8 plus 2, that is equal to 10. Electrons is equal to 10. Now you compare the number of electrons in all these species. Na plus, Mg plus 2, and F minus, O minus 2, etc. In all these cases, the number of electrons will be the same. Number of electrons will be the same. And the species with the same number of electrons are known as isoelectronic species. So all these are isoelectronic species. Mg plus 2, Na plus, F minus, then O2 minus 2. O minus 2, O minus 2. All these are isoelectronic species. So we can define isoelectronic species as the species with the same number of electrons. Now we come to another property. ionization enthalpy, ionization enthalpy, ionization enthalpy. A new term is coming here, that is enthalpy. Enthalpy. Enthalpy is a measure of energy absorbed by the system or released from the system. That is a measure. We have seen the 10th standard, we have seen during exothermic change, exothermic change, do you remember? There is a release of energy, that is energy is released. Heat, for example, heat. Energy of any form, usually heat, is released. Heat is released, that is exothermic change. If a heat is released, then we say the change in energy that is represented by enthalpy change. Enthalpy change. Enthalpy change. That is represented by delta H. Delta H, where H is the enthalpy, delta H. And the sign of delta H is negative. More details we'll study in the chapter thermodynamics. There is a chapter thermodynamics. In that we'll study more about enthalpy change. So enthalpy change is a change in the energy absorbed or released. During exothermic, energy or heat is released. And in that case, we say the enthalpy change delta H is negative. Then, you know the endothermic change. What happens here? During endothermic change, what happens? Energy or heat, say for example heat, that is absorbed by the system. Absorbed by the system. Then we say the enthalpy change delta H is positive. Okay, welcome back. So we were talking about the exothermic and endothermic changes. Let us go back to the ionization enthalpy or ionization energy. Ionization, ionization enthalpy. I told you that enthalpy is a measure of energy of a system, a measure of energy of the system. We can see more details in the coming chapters. Okay. And what is meant enthalpy? You know, a cation is formed by the removal of an electron. Cation is formed by the removal of an electron. So, for example, we have an atom X, and from this, one electron is removed. Then what we get? We get X plus ion. X plus ion. A cation is formed by the removal of an electron. When one electron is removed, we get X plus ion. One more electron is removed, we get X plus 2 ion. One more is removed, then X plus 3 ion, like that. Now you come to this. So cation is formed by the removal of electron or loss of electron from an atom. For the removal of electron, the system has to absorb energy. The system, the atom has to absorb energy. That means it is endo. Okay, proceed. So for the removal of electron, atom has to absorb energy and the positive ion is formed. A formation of positive ion by the removal of electron, that is called ionization. Removal of a cation, removal of a positive ion by formation of a positive ion, formation of a cation by the removal of electron. That is called ionization. Screening effect due to screening effect of the inner orbitals, the attraction between the outermost electron and the nucleus will be decreased, and that property is called the screening effect. Screening effect is maximum for s orbitals because it is spherically symmetrical, so that it can cover the nucleus from all directions. On the other hand, if it is p, there will be the dumbbells along the xyz directions. There will be free space or gap, so there will be more penetration, more attraction. And D, still more attraction between the nucleus and the outermost level. If it is F, the screening effect is the least. So the screening effect of S orbital is greater than P orbital, greater than D orbital, greater than F orbital, and that is the order screening effect. We have to see 2 more points in this chapter, and we can study that in the coming classes. Now, let me stop this.